code, the like top several algorithms, and then you can see those algorithms. They give you the mathematical definition. This is a conventional way to write mathematical definition. You have a definition here. This is really easy. Okay, this one is way too easy. Okay, and then you have an equation, and then you have a where that to define the parameter that's not defined here. Okay, so you have a parameter in this one, and then say denotes this. Okay, and this is the pseudocode for computer scientists. Okay, so basically you have a pseudocode to write up given the input, output, and then begin with the parameter. So I probably have an exam format like, okay, we will hide maybe this, or we will hide this, and then you can, based on this part or based on this part, try to write up the pseudocode or equation. I think this will not be too difficult because you will either have information of this part or this part, and then you write out the other part. Okay, so that's something we are going to do maybe next week, and then you can because this one you probably based on what you have learned. Well, this one is really easy. There's no difficult symbol here. No. Okay. So what we write now, if you look at an equation, is just the symbol you can understand, and you already have the intersection.
The intersection of E and F is all elements that is belong to E and belong to F. It means the overlap.
Yeah. Okay.
Yeah,
okay. And the symbol is like this, right? So I believe you already remember. So that's intersection. So it's this way. It's a reverse way of union, and then. So how many coefficients you have, and don't forget the bias. You have two inputs.
We have two input neurons, and three hidden neurons, and two output neurons. And we have 4 observations. So we have a dot from 4 by
4 attributes.
4 attributes 2.
4 times 2.
4 times 2 and
4 by 2.
That's 2
times 3.
times 3.
Times 3.
And we got the 4 times 3. And this is the hidden layer. We use the root activation function like this. So we times the output weight is WO is 3 times 2. So we got the result of 4 times 2. And we also add the bias at the BH and BO. And we finally got the output for 4 times 2.
So in this thing, they only have one value layer, and my only suggestion is when you write up the wordings, this should be subscript, right? And subscript. So this is important. Like this one is okay, but this one is not okay. This is.
我很同意。这个我很同意。
It's not.
虚心接受。
It's you need to have a WH. Yes. So you try to symbolize it's a hidden layer coefficient, hidden layer bias. Yeah. So yeah. Okay, that's good. Okay. Any other things? Do you have any problem or anything you want to comment? No? No? Okay, let's look at anything.
I think here,
You have something fancy there.
I think this is dimension measures, but I wanted to
Oh, you have something fancy there.
Yeah, I wanted to see here and record and the value will be shown in the next scale.
Are you able to do it?
Yeah, I think for the same.
Oh, really? That's really pretty, yes.
Yeah, so I think it's possible to.
So that's not just the number inside, you also have that. Oh, okay. You guys can think about doing that. Keep, then, like, Warren have this fancy design for the computer matrix he can refer to. So maybe you can try. You can have your current version, and maybe you have this.
这是可以的吧？那你用另外
哦，如果是要做完我把地方
也可以。那你这样子，这所以用那个第二地方。
你们现在先用的现在有按，然后再试看这个fancy版
因为它里面是填满的，就是这个是它的，因为我旅客已经发完，那里面就是然后它的这边就如果是照它就是可以预测到这样，因为我数字发完了。然后 this one is I think the AOL is figure each each method.
bar chart.
Yes.
Okay.
And bar chart is the AOL. And I think here is the dots to show the each method's performance of different. But this is overall. And here is overall to this one. And I think here they do the same with the box charts and the curve for the specific.
How did you get box chart? With the box chart, you need each slide you have a value, right? So how did you line up? Because this is a classification problem. Each slide, do you have a value? You only have whether it's 2 percentage or it's either 0 or if it's I'm just wondering how did you get this box chart? If you can show it, of course it's good. But
Actually,
it's possible. They also have this one. Okay.
But we need to make sure how.
Okay. Okay. So you have the box chart and that's the PR code. AUR seeker.
I think in
each method's overall specificity code. Also in the UNI method.
They also have this
I
one.
think they show you specificity or specificity. I think it's too much mismatch.
And this is the routine part in the top.
Okay.
Here say this for each composition. But I'm not quite sure if feature is for each class or we can do both.
So your design is like different. You have the lesser and for each class. And for all the measurement. Okay. Because in the end, if we say which class we have a really good result, we need to think about how to set up the layout of the table. Very good.
Good morning, everyone. We are presentation a research paper which in medical imaging analysis. This presentation is supervised by Professor Huang and prepared by Danny and team. This is outline. Why choose this paper? Relevance to current research. This study focuses on nuclei instance segmentation. Innovative methodology. Introduction of cell-fit, a vision transformer-based method showing advanced distance segmentation on H&E stem dataset. Dataset validation. Source testing on 3 important datasets: PNUC, mode, monistic concept, showing top-level performance, clinical impact, solve challenges in diverse nuclei segmentation and improve related text with high accuracy and efficiency. Cancer is the second leading cause of death worldwide, just behind cardiovascular disease. Even though imaging technology has improved a lot, diagnosing cancer still
What's the activation function?
Activation function, is there any activation
I
function?
think they only mention review.
You are asking about activation function, right?
Activation function here have not show the function equation. I only mentioned by myself. So 所以是要 activation function 还是
Activation function.
忘在哪？reviewed is not is oh I think maybe I see they not mentioned in the block.
Yeah,
Okay,
they
it's
do
only
mention review, yes.
only here
They
and
mention review.
And the below one also.
Review, yes, they use review.
There's
Two
two
review.
Oh.
And then I have one more question because you mentioned they use focal diversity loss, but here I don't know which part is related to focal diversity loss.
I think it's the cosine.
28. Next slide. You mentioned the focal diversity loss.
Oh,
Which one is focal diversity?
I think it's this one
LFT. Okay. So they say, because can you clarify what's the mechanism why you say they assign higher weights to some instance which is underrepresented? Okay, so this equation, right? So you must have a weighting, higher weight. Which one is the weight?
I think focal is adaptive.
Adaptive?
Adaptive.
Yeah, but it says it assign higher weight for underrepresented class. So why?
Yeah, so maybe you need to see the focal. Because the focal loss is adaptive to calculate
because the original is diversity loss, but the focal focal loss is
adaptive weight for each class.
But which one is adaptive?
Yeah, but it didn't write in. I think you need to see the focal diversity loss, the equation of focal diversity loss.
So, okay. So, in slide 30, you say they still using Harvard's net for post processing.
Yeah, they use the pipeline about overlapping.
And they still, this is something, because they say their runtime is faster than HarvardNet, right? And then they still using HarvardNet post processing pipeline.
I don't know they calculate pipeline using the post.
Oh, so maybe they only.
I don't know they include.
How they compare. Oh, okay. Because they still apply a lot of image processing, right?
Yeah.
They apply SOHO and then they use marker control watershed algorithm. Okay, so they basically still use a lot of image processing technique. Okay. And you say they have some alternative decoder. What do you mean this one? They also
in the
compare.
experiment they compare this decoder, different decoder, encoder, different encoder. So studies, studies or something.
So they compare different decoder.
Here, SD is studies, and the CTP next is used here as a.
What the conclusion is? Which one is the best one?
Best one is use SM and VIT because the It's HAB, it's HB. Decoder is HB. Oh, this one is decoder.
This is this decoder,
Yeah,
yes.
decoder.
And I think they just proposed a hyperparameter. This HP means a hyperparameter. Or what's the CP? What's the CPP means? CPP net. Okay.
我也不知道它是 hyper 最主要用在哪里。
Okay. So how is about slide 42? They mentioned they have oversampling strategy, okay, because due to some underrepresented samples. So can you clarify how they perform oversampling?
I think this center maybe I mentioned.
No, slide 42.
42.
You have the oversampling, and then you have an equation about oversampling. Can you tell me how this oversampling strategy is performed?
I
This
think
is
it's
customized.
very complex. Sampling their sampling PI. They say their sampling is equation 10, and the W tissue and the W cells is compared by this function. But how they use in
No, for example, like in our case, if do they means if certain type of a tissue is underrepresented, they will sample it twice.
Yeah.
So they basically train it twice. So they sample more the same data, just like what we did, like bootstrapping. We put it into the training set. Okay, so but they didn't apply any augmentation. They just put it the same sample into training. Their oversampling strategy. Here I can only see they sample more times.
Yes. But I don't know if sample first or augmentation based.
Okay.
I think they did some augmentation.
They did apply augmentation.
Yeah.
So maybe they just put it into the list, more the same seal, put into a list, and then they apply augmentation.
I think it's this one because they mentioned they use another library to augmentation.
Which library?
Augmentation is one.
Oh, I know that. Then Admin also do that.
Yeah. Oh.
Okay, so they use this to do augmentation. Okay. Yeah. And in 43, you mentioned that they unfreeze. In the training, I think this is interesting. In the beginning, they freeze encoder weights for 25 epoch. They freeze encoder weight for 25 epoch to train the decoder.
Yeah, encoder is a precision weight from SM and VIT. They freeze don't let the weight not multiply or something. And then after the 25 epoch, they train whole the model. So I think this they mentioned.
So when they say they unfreeze encoder, it means they can also update the weight of encoder of the encoder as well.
Yes.
So they didn't just use the encoder, they also train the encoder.
Also train the encoder, I think here.
Okay.
They mentioned it.
So I think it will cost a lot.
Yeah. So they need to large memories.
They have a very expensive hardware.
Because the 1024 pixel.
Oh.
The base model is in the pixel size.
Okay.
Maybe 256 we can do the 1024.